Hello and welcome to Database Management Systems. I'm Jovita Christie, and in this video, I'm going to explain to you the network models and ER models in DBMS. So let's begin. The network model looks something like this. This is the diagram, and it's fairly simple if you try to create it because all that you need to do is just put um, different people or different objects together. And whenever one object is related to another object, you just show it with a line. So you can see here in the diagram that employee 1 is related with departments 1, 2, and 3. And so there are lines going from employee 1 to departments 1, 2, and 3. And so also employee 2 is related with departments 1, 2, and 3. So there are lines going that way. Same with employee 3. So it's very simple to create, but it's complex when you have several objects. If you were running a department that had 100 employees and you had 100 departments, not 100, maybe let's say there are 15 departments and 100 employees, then you'd go mad creating all the lines everywhere. So this model is not a model that is used in practice, but it is still studied just for the sake of it. And these are some of its features. The first feature is that it provides a flexible way of representing objects and other relations. Each record can have multiple parents and child records, so it's a lattice structure. Any item, it can be directly related to another item. And it's slow, complex, and difficult to maintain. Also requires a complex diagram to represent a database. So all of these are the features of a network model. Although it's a very flexible model wherein you can decide what you want to put and what you want to connect, it is still very difficult to create it. And each record here can have multiple children, multiple parents, and because you can connect anything upwards, downwards, and that's why it forms a lattice structure. Any item here you can directly relate to another item, regardless of what the item is. And it is slow, complex, difficult to maintain because suppose you had to remove something from here. For example, there's a department that you need to remove. Then you'd not only have to remove the department, but also all the lines that are connected with that department. So that is why it is difficult to maintain. If you want to change somebody's department, then also you'd have to make changes in two places. One is you have to remove the original department and then create another line to go from that employee to the new department. That is why it says that it is slow and complex to maintain. And also the diagram becomes more and more complex as you start adding more objects into your database. If you have lots of tables, more number of tables, then the diagram becomes really complex. This brings us to a more efficient way of representing the database, and that is the entity relationship model, which is also known as the ER model. And in ER model, the E stands for entity sets. So first we're going to see what an entity set is. So an entity is a thing or an object in the real world that is distinguishable from all other objects. And it has a set of properties and values which can uniquely identify each and every entity. And an entity set is a set of entities of the same type that share the same properties. Now here you can see, suppose you are in a university, then you're going to see a lot of people. So you can say that person is an entity. And then that person could be anybody. It could be either a student or a professor, depending on whatever you'd like. So the person entity it is a thing or an object in the real world, and you can distinguish it from other things on the campus. For example, there are trees. You can distinguish a person from a tree. or from chairs or tables or stuff like the animals. So because of that, it's a separate entity in itself. And it has its own properties, like every person would have a name, every person would have a phone number, every person would have an email ID, and so on. So that's why it is known as an entity set. So an entity set contains a set of such entities. So person is an entity set that contains all these entities together stored in it. Now the R, which is present in the ER model, that R stands for a relationship set. What is a relationship set? A relationship, first of all, is an association between several entities. So if you have one entity and another entity, and you might want to relate them, for example, there's a student and there's a professor, and you want to relate them by saying that this professor teaches this student, then you would say that that's a relationship between the professor and the student. So it's an association among those two. And a relationship set is nothing but a set of such relationships. If you were thinking in the form of a relational model, then what you would be doing is create a table for students and create a table for professors, and then create another table which says which student is being taught by which professor. So this table would be a relationship set. Now, there are several types of relationships, and the first type is a unary relationship. It's also known as a recursive relationship, where the same entity set participates in a relationship set more than once in different roles. So if you see here, I have a course relation, a course entity set, and I can relate one course with another course by using prerequisites. For example, if I want to learn advanced algorithms, then I do need to know basic algorithms first. So this whole concept is where one course is related with another course. Advanced algorithms are related with basic algorithms. So basic algorithms are a prerequisite for advanced algorithms. And so although both are belonging to the same entity, it is forming a relationship. And that is called a recursive unary relationship, which you can see it is represented in the diagram like this. All entities are represented as rectangles. So course is in a rectangle. All relationships are represented in rhombuses or diamond shapes. So prerequisite is a relationship. So prereq is there in a rhombus. And then there are two lines going in and out of course, and those lines show you the course ID, which is the course, and the prerequisite ID, which is the course you need to study this particular course. So that is how unary relationships are. Next, we have a binary relationship, which you can see here. So it's a fairly simple relationship between instructor and a student. Instructor teaches a student. Instructor and student both are entity set. Teaches is a relationship set. There can also be a ternary relationship, as you can see, between instructor, student, and project. And the relationship between them is called project_guide. Now, you don't have to always have a name for the relationship. You can name it whatever you like. And if you cannot come up with a name, you can just combine the names of the entities and form the name of a relation. It's all right. So a ternary relationship has three entity sets involved. And this is the type of relationship that says one student is working on one project, and then one instructor is guiding that student as well as that project that he or she is working on. So that's a ternary relationship. And now we're going to discuss a little bit more about the different types of properties of entities. So attributes are known as properties. And there are several types of properties which we're going to see next. But let's just define what attributes are. Attributes are descriptive properties possessed by each member of an entity set. So let's first see descriptive attributes. First of all, whatever you can see in this diagram in the form of circles or ellipses, they are all attributes. For example, instructor is having attributes like name and first name and last name, that should be an L, and some ID, and student is having contact, date of birth, and age. Doesn't mean instructor doesn't have those. It's just to show you different types of attributes that I have added it in that way. So first you're going to see a descriptive attribute. A descriptive attribute is an attribute that's associated with a relationship set. Now usually relationship sets do not have attributes. Usually, because most of the time we attach attributes to entities and not relations. But sometimes, due to some anomalies, we have to attach it to the relationship. So in this case, you can see that there's a date attribute, and that attribute is attached to the teacher's relation and not to instructor or student. The reason for this is that if I want to provide the information about on which date an instructor started teaching a student. So to put that date, I have to decide whether I want to put it with instructor or student. And the answer would be neither, because if I put it with instructor, the instructor is teaching so many students. I cannot add a date column with the instructor, with one instructor, several date columns, because that instructor is teaching so many students. And so also for student, one student is being taught by many instructors. So I cannot add several dates with one student and say that this instructor started teaching this student on this date. So the best way, the most logical way of putting it would be with teachers, because in teachers, I have instructor's ID and the student's ID, which already forms a relationship. And next to it, I can just add a column date and say that this instructor started teaching this student on this date. So it's fairly simple. And the next type of attribute we're going to see is a composite attribute, which can be divided into subparts. So for example, the attribute of name, you can divide it into subparts by saying that name can consist of a first name and a last name. Let me just draw your attention to the symbol of a descriptive attribute. A descriptive attribute is drawn just like everything else, all other attributes in an ellipse, but when it is attached with the relation, it is attached using a dashed line. So it's not a solid line, but a dashed line with gaps. So that shows you that it's a descriptive attribute. And composite attributes are just shown with ellipses, and because one attribute is divided into subparts, you can just put it in this manner and show it as one ellipse from where multiple ellipses are coming out. Next, we have a multi-valued attribute, which you can see right here in with the students. You can see contact. Contact is a multi-valued attribute because it can have more than one value. So if a student has multiple mobile numbers, then you can say it's a multi-valued attribute. And to show such an attribute in the diagram, we draw double ellipses instead of a single one that we do with any other ordinary attributes. Next attribute is the derived attribute, whose value can be derived from the values of other related attributes or entities. So for example, you can see there's a date of birth attribute given. Now, if I have somebody's date of birth and I want to find their age, it's fairly simple. I just have to subtract the date of birth from today's date, and that would give me the age of the person. So from the date of birth, I can derive the age of a person. And so age is, as you can see here, is a derived attribute. Now to show this derived attribute in the diagram, I need to create an ellipse, but without the solid line. So I won't be creating a solid line. I would be creating a dashed line, an ellipse with a dashed line here. So that's how you show a derived attribute. This is not to be confused with the descriptive attribute, where instead of making a dashed ellipse, we make a dashed line to connect it. So that's just something that you need to remember. So I hope you understood all the entities, relations, and attributes that I explained here. This is just the basic of an ER model. There are a lot of other things to show in an ER model, and we are going to see that in the next video. So I'll see you in that one. Thank you for watching.